Hello everyone, this is Pawan here. So this is the project I've worked on for the CS665 course. It's called Name Your Price System. Basically, it might sound something that Priceline has, Name Your Price, and it does have certain elements of that as well. So let's look at the functionality of this application first. So the main theme of this application is, so typically a customer goes to the business and makes them profitable by buying their products. So using this app, the businesses will come to the customer competing for the business. So typically, in today's world, we go to a retail store, online store, and we go and purchase things. And actually, the customers, the businesses do make profit out of it. So here the attempt is to uh, before even we go to them, they come to us and grab our business. So Name Your Price app is an attempt to leverage technology to share information, which is our wish lists, and promote fair competition. So let's look at a use case of the end to end, and then probably we'll go from there. So the complete application, the way it works is the end to end scenario is, so the customer creates their wish list. So this can be any item they want to buy, any single item, on a mobile or a web app. So there are different applications. In fact, I did work on one of similar applications in my mobile class where I developed a wish list app. So something of that sort, where you can enter your wish list, any item that you want to purchase on mobile or web app, which is integrated with the Name Your Price platform. So this is the Name Your Price platform which has worked in this class. So the wish list will be taken, imported from there into this platform. And what this platform does is, so the vendors register with the Name Your Price platform. So these vendors can be anyone. So it can be a Amazon, Google, Walmart. It can be a mom and pop store. It can be a small, like a farmer's market. It can be anyone who can sell items at the most competitive price. It doesn't have to be, you do not need to have every single item in the world to sell. You can sell like a bunch of few items where you think you're the most competitive. So you go, and so all these vendors register with the Name Your Price platform. And then whenever the wish list comes, the system broadcasts the wish list to the registered vendors. So what the system does is, it scans the wish list first, the customer's wish list who wants to buy. So it scans the wish list to see what items are there in the wish list. And then it goes and scans all these registered vendors' catalogs to see if these vendors carry all these items or not. So based on that, it selects those vendors and it broadcasts the list only to those vendors, not to everyone. So then the vendors provide the lowest bid, whatever the best they can give for that list, for all the items in the wish list. So now the customer receives the minimum bid. So the system sends the minimum bid to the customer. The customer can accept the bid. So the customer is okay with the price and they say okay, and then order will be delivered. Or they are not comfortable with the price and they name their own lower price. So this is a flexibility which we do not have today. So we just go online retail price and whatever the price we see, we just buy. We don't negotiate there. So here you can negotiate, you can name your own price. So what happens then is, so you get you have 10 items in your cart, and then the amount is like $100, and then you think like maybe 80, 85, 90 is a good price for that. So you can give that counter price here. So the system then sends the customer's lower price to the vendors. So whoever vendors have bid, so starting from the lowest bid, it sends to vendors one by one. So if any vendor accepts it, then the wish list order is delivered by that vendor. So it doesn't have to be the vendor with the minimum price. They may not go further down, but some other vendor might want your business. So they may go down based on their margins and whatnot, based on their own algorithms, and they can match your price. So, and if none of the vendor accepts the price, then the same order can be broadcasted later. It can be done by the system every second day, or the customer can initiate it again. So let's see how this functionality has been designed. So the design patterns that have been used here are the singleton pattern. So the Name Your Price system itself is just one system in the whole application. So that's a singleton, and that is the one that actually gets the best prices and whatnot. So the facade design pattern is what hides the complete complexity of this whole system from the main client. So main client have only exposure to only two methods in the facade. which are create a wish list and then get the best prices, and everything is hidden behind the facade. Observer is something I guess we have worked in earlier projects also before. So this is the pattern where in um, the Name the Price platform broadcast the wish list to all the registered vendors who qualify for that wish list, and it gets their prices and then it negotiates through observer pattern. The bridge pattern is where the many-to-many relationships comes into picture. So here we have a lot of vendors and we have a lot of products. So any vendor can have any product. So that's where the bridge pattern comes in, where like, the abstraction in this case, where it's the vendors and the implementation, which is the products. So they can add whatever products they want. Chain of responsibility is basically when a vendor wins a order bid, that order will be delivered. So in order to deliver, so like so the wish list is like a shopping cart. So once your shopping cart is done, you do a checkout and it goes through like calculation of tax, calculation of shipping, making the payment, and then packaging the product and then shipping the product, right? So it's like a bunch of stuff that needs to be done. So that's like a chain of responsibilities, a design pattern which takes care of that. So looking at a very high level UML diagram here, it doesn't have all the classes, but it has all the major classes for the design patterns. So this is on the left side here. We have the main class, the driver class. It calls the facade to run this program, and the facade exposes two methods: create wish list and the get best prices. So the create wish list is the first method which is called. So it goes to calls the wish list client. So the wishlist client first needs to load the orders, load the products in the stores. So it goes, it calls the vendors to load the products. So this is the bridge pattern which comes into play here. So this is the abstraction, which is a hierarchy of the vendors, and this is the implementation, which is the products which are going to be added to all these vendors. So once those products are added, and then the wish list is made, and the facade calls the get best prices now for those wish list. So it calls the name your price singleton. So this is actually the platform. This is what actually manages all those getting the bids and whatnot. So this is a singleton, which is only one class for the whole application. So once it gets the wish list, it goes one by one over the wish list, and then it sends the sorry about that. So it goes over the wish list, and it sends to the name your price system here, to the vendor client, name your price system. So this is actually the observer pattern. So this is a subject, and this is the name your price system which implements it, and then this is the observer, and this is the vendor which implements the observer, and these are all the observers. So it broadcasts, so name your price system broadcast to all the vendors, and then it gets the bids, and then the name your price system calculates the minimum bid and all those logic is here. So if you see here, the vendor class is, it's a part of the bridge pattern here, and it's also the part of the observer pattern here. So it's the right side of the observer is observer, and then it's on the abstraction side of the bridge pattern. So once it gets all those prices from the vendors, it does all logic, checks with the customer, minimum bid and whatnot. So it goes through that, and then once the wish list is finalized, it sends it for deliveries for the items to be delivered. So it sends the order to the driver client. So what the driver client does is it just passes is to the chain of responsibility here. So this is the chain interface which has multiple implementations. So it can be different actions that can take place. So here it's going to push it to the tax here. So it calculates the tax, and then internally it sends it to the shipping amount. It calculates the shipping amount. Internally it sends to the payment, and then it charges the payment and sends for packaging, and then it sends for shipping. So it all happens internally. So this is a chain of actions that happens. And since this is a new design pattern which we have not learned in the class, we can look into more detail of this. So this is like the overall 10,000 feet view of this whole application using facade, singleton, and there's actually a small item builder here which I was planning to use the builder design pattern, but I did not see a lot of uses for updating the items and whatnot. So that hasn't been continued. But yeah, there was a scope of using the builder pattern for building the items. And I do have an item builder in this project. So we have the facade, the singleton pattern here, the builder partly, and then we have the observer pattern for broadcasting, getting the prices, and then the bridge pattern for loading all those vendors with all those catalogs, and the chain of responsibility to deliver the products to the customers. So now looking at the new design patterns, which we have not learned in this class. So chain of responsibility, this is the snapshot below from the head first design pattern book. So this basically says with the chain of responsibility pattern, you create a chain of objects that examine a request. Each object in turn examines the request and handles it or passes it on the next object to the chain in the chain. So basically here, so chain of responsibility is a behavioral design pattern that processes a request. So the request here is the order. So we get an order, we need to process that through a chain of handler objects. So handler objects are, okay, tax it, okay, calculate the shipping amount, charge the payment, and all those kinds of things. Those are the handler objects. So the request is passed through the chain of handlers and might be processed by one or all the handlers. So depending on, like, say, tax. So the customer address is Delaware. Delaware doesn't have any tax, so it may not calculate the tax and just pass it on to the next one. So it depends on the logic that you implement in that. So this is a definition, and this is how it has been used, the use case in this particular app. So after a vendor wins the order goes through the delivery process. So it calculates the tax first, calculates the shipping, process the payment, pack the order, and ship the order. And here is a small code snippet and the UML diagram, which was pulled off Eclipse. So so this is a delivery client. It passes the order through this pipeline, and it just goes and flows through the pipeline and gets delivered. So you can see here the chain interface is implemented by all these classes, and then they all have this set next chain method. And the set next chain method, they can put whatever they want. So you can change the order, you can remove one from here, you can do whatever you want. This is very flexible design to do a lot of calculations. So the problem at hand was when there are multiple parameters to be validated, typically multiple if-else statements are used. So depending on the number of conditions, these can become unmanageable. So you can imagine taxes, shipping amounts, payments. For all these vendors, for all those business rules, there can be several ifs and else, and it can become a huge mess, the code. So object-oriented is a very clean way of doing it. So chain of responsibility is a clean object-oriented way of handling large conditional validations and flexible enough to remove, add validations without changing existing code, just by adding, removing, changing order of objects. So this is basically honoring the open close principle. So you do not have to, like, change any code if you need to. Say if it's, like, everything is tax free, say tomorrow online orders are all tax free, so you can just remove that component from there, and that's pretty much it. You don't have to do anything else in the code. Say tomorrow you want to add a coupon code, so there's no coupon code right now. You may have a coupon code option when you do a checkout. You just create one class and just pass it into that in between, and you're good. But if you add a if-else statements for all those things, it can become pretty messy. So this is where I think most of the design patterns comes when it comes to honoring the open close principle. So the pros are, as we discussed, decouples the sender of the request and the receiver. They are completely different. Allows to dynamically change the members or order of members of chain. As we discussed, you can remove them, you can change the order, or you can add more stuff, more handlers, like more actions. It simplifies your object because it doesn't have to know the chain structure and keep direct references to its members. It's kind of a pipeline through which your request flows. So basically, you do not have to worry about where my tax object is, what it's holding right now, what is my data. You don't have to worry about all those direct references to all those classes. You just pass it in the beginning of the pipeline. The order is delivered by the end of the pipeline, and all the logic stays there. So you are hardly worried about keeping references and all those other objects. So, and the cons here is it can be hard to debug and observe the runtime characteristics because it gives you so much of power there. So it's debugging can be a little bit difficult here. And here is one more example that I got online, which I thought might make it easier to understand the chain of responsibility. So like so you need to draw $455 from an ATM machine. So these are the chain of responsibility components. So this amount goes here. So first to the $100 component. So it will do a mod 100 of this amount, like $455 mod 100. It gives the four bills here. Okay, these are the four bills, and it passes the remaining $55 here. It does mod 50 and say, okay, I have one bill for you. It gives one bill. What remains is $5. Passes here. So 20 says 20 mod 5. So this 0 is, so it doesn't give any bills. It passes a 5 here. Now 5 has like it's one bill. It just passes and then nothing remains after that. So they all give those bills and it gives the cash out to the customer. So this is one way of doing the chain of responsibility where you're giving a part to everyone. They all together does a job basically. So that's another example to make things easy to understand. So that's the chain of responsibility principle. And since I worked on a couple of new design patterns, I thought I can quickly go through the bridge design pattern as well. I'll take like maybe a couple of more minutes, not a lot of time. So bridge design pattern, the definition is actually it's like a many-to-many relationship. So if you have a scenario where you have many-to-many relationship, in my case, it's like too many vendors and too many products. So there is ideal case where you can just build those things. So you're like, say you're creating a video game and whatnot. So you have different, objects, characters and stuff, which is on the left side, abstraction. It can be like, like a hero, villain, heroine, the objects like a circle, sphere, triangle, rectangle, all those things can have different, say that they can be colored in different ways. When they're happy, they're like, yellow, I don't know, like green. When they're angry, they're red. So they can have all different kinds of colors here. So you do not need to create a green circle or a red circle. You just create a circle, that's it. And you create all these colors here. So whatever you want, you just take one from here and take one from and just mix them basically. So that's a bridge. So it's completely decoupled. That these two hierarchies are totally decoupled, and you can use every one of these can use every one of these basically. So it's like a many-to-many relationship. So the bridge design pattern is a structural design pattern which allows us to separate the objects abstraction, which is on the left side here, from its implementation, the usage, which is on the right side here, so that both can exist independently. So you do not have to mix. You do not have to have a red circle, green rectangle, stuff like that. You can just have rectangle, circle, and whatnot, and we'll decide the behavior in the runtime what you want. So you can just make it the way you want it, many-to-many relationship. So the problem at hand is when there is a many-to-many relationship, bridge pattern comes in handy. Instead of creating many times many classes, it can do the job in many plus many classes. So if you have like say 5 objects on either side, instead of having 25 classes, the permutation combinations, you can just have 10 classes and it's easily manageable. So the use case here is the challenge I had was in this case I took 5 vendors and not all vendors sells everything, and there are 5 categories. So there can be many going down the line. So each vendor can have up to 5 categories of products. So I need to give like one product to one vendor, 2 products to one vendor, 3 products to one vendor. So I need to have the flexibility. So in order to get all permutations and combinations of vendors with category, 5 times 5, which is 25 classes are needed. So using bridge pattern, this problem can be solved using 5 classes, 5 plus 5 classes. So here is a quick implementation. The implementation product, which is this guy, on the right side of the implementation, is passed to the constructor of the abstraction, which is the vendor. So if you see here down, say Amazon, Walmart, they have a constructor here, the product. So this is actually this right-hand hierarchy. This one product is nothing but it can be a million products. So this guy can have all these products because all are of type product. You can have a produce, you can have a bakery, you can have toys, you can have flowers, you can have whatnot, like chocolates, anything you wish. So below this is a code which I have taken like from my code. So here you can see load mom and pop bakery. So this guy sells only bakery item. They do not sell anything else. So just say mom and pop bakery, which is a vendor here, and then you have a product which is a bakery item. So now they have the bakery catalog, they have the mom and pop catalog. Farmers market has got flowers and produce, so they create their own catalog. So they just pick and choose what they want, and they can create their stuff. So that's the where the power of bridge pattern comes into play. The pros are can make several objects do several things, as we said, discussed, right? So we have a hierarchy of 10 on left side and 10 on right side. So we need another, say we make it 11 on the left side, so that one additional item that we just added on the left side have already got access to all the 10 items on the right side. You don't really do not have to, do anything more than that. So that's the power of this thing. So it can make several objects do several things. Objects and behaviors can be easily extendable using open close principle. Again, like, if you need to add a new like a shape or new vendor or whatnot, you can add it on the left hierarchy. If you need to add any more products, more behavior, more colors, you can add it on the right hand side. So it's like, easily extendable. And cons is, since this is solving a pretty complex program, I mean, like, it's like, there are too many, stuff is handling, so this can get pretty complex. So there's a con of this. So this is pretty much, I think, the demo I had, and we can quickly run through this app once, since and see how it runs. It should not take more than a second to run it, and then we can see the output, what actually is. I have logged a lot of things in this, so we can see. So this is a program, projects assignment 7. Let me just run it real quick. Sorry if I took too much time. I just tried to do it as fast as I could. So this is the program that we just ran, and then we can just look at a little output here to see what actually is doing under the hood, so that we know what the whole idea behind this is. We can take an order. Let's take some sample order here. So this is this is all random. It's running random, so I have no idea what this is, but I'm trying to find something which may see some value in this. So if you see the item number 3, the wish list 3, so once the wish list was broadcasted through the observer pattern, so the minimum bid received was $43 from Walmart for that particular bid. So this actually list has all these items in it: toys, produce, bakery, flowers, frozen, and whatnot. Since it's all random, so it just so this list had all these categories, and then Walmart, Google, and Amazon are the only 3 vendors in my current program which handles all the categories. Farmers Market can handle only 2. And the bakers can handle, the mom and pop bakers can handle only 1, so they are not qualified for this product. So this order was broadcasted to only Walmart, Amazon, and Google. So Walmart actually bid the least first, $43 for this order. So minimum bid price $43 from Walmart is not acceptable to the customer. Customer is not happy with 43. So customer wants to pay only $35 for this. So customers say, you know what, this is too much. I just want to pay $25. And then now the system is checking with the vendors, starting from Walmart. Okay, can you make this 35? So starting from the lowest bidder. So congratulations, you just saved $8. So a vendor actually accepted this, and it was Amazon. It was not Walmart. Amazon accepted it. Amazon accepted the customer's name your price of $35, preparing the order for shipping. So now this goes to the chain of responsibility. So tax is exempted for Delaware. So this customer is from Delaware, so the tax logic there says it's exempted. The shipping, since this is from Amazon, the order qualifies for free shipping about $25. So this is a $35 order. So all this logic is there in that code. So congratulations, you qualify for free shipping about $25. So Amazon orders for $35. So free shipping. So yeah, Amazon credit card. Again, this is customized. So it's using the Amazon credit card and not like a Walmart credit card or Google Pay or something like that. And then your order has been packaged, and then your order will be shipped within 2 days using Amazon's Prime delivery service. So these are all like, customized as per the vendors. And order has been shipped. Here is your tracking number. So this is basically the whole this whole part. The end part is the chain of responsibility design pattern in play, which handles all these permutations and combinations of different logics for different vendors. So I guess that's pretty much it. And I hope I did not take too much time. And thanks for watching.